Alright, I guess part 2 on the Professor Lewin magnetism video. Holiday, I guess you have to pay a price for your defenders, so Professor Lewin will have to pay the price. Because I'll point out some more errors in what he said. Anyway, so Holiday writes, Holiday who can't articulate a point in some sort of polite or reasonable manner, like saying, I think you've made a mistake yourself, or something like that. So instead of, it's just obnoxious declarations by this science slob. You haven't spotted or explained a mistake by Walter Lewin, exclamation point. You have just described the complexities that lead to a real change in the magnetic field of the second arrangement. And the argument is the way the change was described was inaccurate, as if the magnetism gets weaker, or the force gets weaker. It doesn't, in fact. The nail falls because the nail loses its magnetism. The force of the other two magnets was actually increased. Anyway, you state that it that it is the magnetism of the nail that changes. Yes. Why did it get magnetic? Because of the field. Well, again, he didn't describe it that way. He talked about the domains of the other ferrous material. He never talked about the domains of the nail. Not once in the whole frickin' description. You made field. Why did it change? Because the field changed. Well, again, the idea of the field changing is fundamentally wrong. So Professor Lewin's rhetoric is closer to the truth in talking about the configuration. Now, again, to argue, I can use his explicit statements where he says the field decreases over here. The strength decreases when it doesn't. So I'm just saying he's wrong, and I pointed out where he was wrong, and you're not responding to those wrong, if not direct statements, implications. He clearly at the end said the nail falls because the magnetic force decreases, not in the nail, but in the other arrangement. Alright, you have just made an intuitive argument. So again, playing this game. The exact argument I'm making is exactly the opposite. I'm making the technical argument. Professor Lewin made the intuitive argument, which was, look, if I bring another magnet in here, it uses up the magnetism somehow, and the nail falls. When that's not what's happening. When I bring another ferrous material in there, I actually increase the strength of the magnetism. If he had the nail turned the other way, horizontally, it wouldn't have fallen. It was only because the nail couldn't orient itself to the strong field that it fell. That's it. So again, I'm making the technical argument, the accurate argument. He, Professor Lewin, is making the intuitive argument. So you have it exactly backwards, and you're such an arrogant, yob in doing so. That is entirely consistent with Walter's. Well, again, the two arguments aren't consistent at all, and I think that was well demonstrated in the video. So that's just nonsense. I mean, you can say it, but it's nonsense. Further, never did I get how your system gets around the creation of complete monopoles of north and south by breaking a magnet in two. Well, I've been over it 4 times at least, and many more times than 4 I have stated that magnets are made out of magnets. The elemental magnet is the atomic dipole, the electron and proton. That's the elemental magnet. You can't get a smaller magnet than that. You can have monopoles of an electron and the monopole of the proton. Well, let's say the neutron would be the smallest magnet. but you have to have an electron and a proton. Alright, I think you say it just suddenly rearranges back to a dipole. No, I didn't say any such thing. I mean, I showed it in the, I believe it was in the 30-minute video I just did, but I pointed out the triangle domain idea, the fact that the magnets are always staggered. So this is the piece of paper I used for the 30-minute video. Here's the magnet. The idea would be, as pointed out, the outside surface ends up being predominantly red, and this one's predominantly black. And the trick is the dots represent the atoms. You can't break the atoms, so you can only break the magnet in between the atoms. The atomic bonds between the atoms will break. The bonds inside the atom will not. You can't break the relationship between the proton and the electron. You have to separate. The atoms will separate as atoms. They will not separate as partial atoms, because that requires, high energy physics. That's alchemy. So when you break the magnet, nothing changes. The magnet's exactly two new magnets. It's can be compared. What did I do with my little string of magnets I had here? Well, that's disappointing. I did put them aside to say, hey, use that for a demonstration. They must have got magnetic to something. Here they are. So here's a bunch of magnets stuck on end. Now the problem with this is they're not breaking on the true atomic level, and they're not forming on the atomic level, so they become sort of out of phase, would be a way to say it. And so you can't just you can't point out exactly how it works, but I'm just saying I can break these magnets and break these magnets and break these magnets, and I'm not changing the magnets at all. So it's just that simple. Every magnet, if you think of these individual magnets as atoms, every magnet is just made of atoms, and they'll break between the atoms, and that sort of guarantees this side will always stay red and this side will always stay black, because it's always going to break on this dotted line. Alright, but like I said, I've been over that, so to claim I've left some doubt, I think is again, I think it's just more exaggeration and nonsense on your part. Alright, complete monopoles, north and south cutting, breaking. I think you say it just suddenly rearranges back to a dipole. No, it's always the dipole until you get down to the single atom or to the single neutron. To be consistent with observation, but this requires an explanation. Well, I have already explained it. To just say so is to invoke your own magic. So I never just said so. So again, that's just nonsense. More disgusting and putrid rhetoric. If you're going to keep making comments like this, then yeah, I'll just block you. Because I don't have to defend myself against those stupid accusations. Classical theory doesn't need to do this. Well, my whole point is classical theory isn't accurately describing any of this. And I'll show Professor Lewin doing it wrong again, if that's what you want me to do. It is entirely expected that to break a magnet in two is to create two regular magnets. And as I'm not going to reiterate it, but I've said that in at least 4 videos. So your accusation is baseless and rude. Alright, so getting to the what does Professor Lewin say? Alright, let's get first to this. So when he draws these lines, these field lines that they draw like it's a current, there's no such current. There's no such any of this nonsense. There's not going out at this end and coming in at this end. None of that is accurate. It's just a wrong way to describe it. And this divergence here isn't real. The force here is coming out quite straight. So see, these field lines end up being a field line and force line ends up being a tricky thing, but you have to Alright, let me try to draw that. it's, as I did illustrate in the other video by showing the other diagram, what a magnet does is it radiates like a light bulb. And so all it's doing is taking field energy and converting it. So all the light that comes out of the top of the magnet is red, and everything comes out of the bottom, let's say, is black. And the trick is some of the black goes into the red and some of the red goes into the black, except at the two ends. I'm just drawing the same thing I've drawn before, but this is the real force. So the real force is like light, little energy bits flying in dead straight lines. I shouldn't have drawn black there, but dead straight lines coming out. So it's radiating one color force, one polarization out of the top, and radiating the other out of the bottom. And the purer that is, the stronger the magnet. Obviously, the more noise you have, where you have extra reds coming out of the bottom or extra blacks coming out of the top, means you have a weaker magnet. So the strength of the magnet, like a N50 or something, or 60 or 100 or whatever, just means you've gotten it so pure, taking out all the crap that would create any noise. And of course, the colder you make it, the more it'll be pure, in the sense that you'll be able to keep the domains stable and properly oriented to produce red out of the top and black out of the bottom. So the field line is just saying what happens if I put a compass, a little magnet. What happens if I take a little magnet and I put a little magnet around this magnet? Which way will the little magnet point? And so it's just telling you that, well, it points this way here because there's field strength from both sides. It points straight in here, okay, coming out, because the north is clearly dominant and there's nothing the south end of the magnet can do, and vice versa here. And that's the nature of your field lines. So your field lines, really, this is just going straight, and as soon as you cross this edge of the magnet, well, then you start bending the compass, because now there's black influence that goes this way and it can get over there. So now you have a little bit of black leaking in, and a little more and a little more, and that's why it goes flat, and it goes flat and flat, and then does the bend around again. So the field lines are completely not a real thing. They're just what a test instrument senses as the strength of the light. It's just measuring how red it is, how black it is, or how mixed it is. And so the lines mean almost nothing. But the trick is when these lines are formed by the test instrument, so if you take a bunch of compasses and put them on the top of a magnet, so just imagine those are compass needles, and they're all going to point to the north end of the magnet. What's going to happen is they're all in phase with each other. They're all lined up. So they're all going to go north, 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 and south, 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 south. Say this is the north side of the magnet. So the bottoms are all going to go south. Well, the problem is now they're repelling each other because they're all oriented exactly the same. So now it's not this force that's actually bending. So when he draws these lines bending, it's not the force of the magnet. This field is not bent at all. If nothing else is here, this magnet's alone, these lines do not bend at all. It's only when you put the test instrument in, which is another magnet, and those magnets are repelling each other. And so the test instruments start affecting each other and pushing the field lines out because they're creating repulsion because all of these magnets are lined up with each other. And so it's not the magnet didn't change at all. The energy coming out of the magnet is still dead straight. But the effect of your test instrument is to bend because the test instruments are repelling each other. Okay, so that's his first mistake. This doesn't happen. This only happens to test instruments. It doesn't happen to the actual field. The actual field does not change at all. The test instruments spread because they're affecting each other. Jeez.
Dipoles are going to align themselves. They're going to create themselves a field in this direction. They're going to support that field.
Now, what does he mean by that, Hafliday? They're going to support that field. They're not going to support anything. There's nothing going to move over here or do any of this stuff. What's going to happen is this red radiation. Let's just say this is red coming out of this black magnet. It's coming straight out of the bottom, and it's coming out at angles from the side of different strengths of N-ness, okay, redness. And what it's going to do is it penetrates this material, and when it hits the atoms, it turns them, and they end up turning into alignment like little compass needles. They are affected, and they line up to become south and north. But nothing's moving between them. There's just this energy, this light hits this thing and starts making it create light in the opposite color. Now, you're going to tell me that's what he's saying? That's not what he's saying.
And so the net result is that the field inside here becomes very strong.
Okay, now the field inside here becomes very strong. Now, is that accurate too? Is that what's really happening, or is he saying this thing starts lighting up? This piece of stuff starts becoming a light bulb and also creating filtered rays. So this one's creating filtered rays. It keeps doing it exactly the same amount as before because it can't change. It's a permanent magnet. It can't get stronger or weaker. It's going to filter just what it's filtering. But this little light bulb starts lighting up, and it's creating the black stuff, and this one's creating red stuff. So now you got black shooting out this one, and you got red shooting out of this one. Filtered. Filtered. Key word.
And so what happens with these field lines, they go like this.
So the field lines, again, what happens if I took a compass and put it here, the lines the compass needle would line up in a different orientation because now there's a conflict between north and south, and there's clearly, instead of going straight, the south is going to go here because there's more of that black stuff coming out here. And so the funny thing he says here is this becomes a much stronger magnetic field. So it's actually a stronger field the nail is in. It's actually a stronger field if the nail was oriented this way. If you change the position of the nail so it could turn, so one end could become north and one end could become south in orientation to this field, it would have moved stronger into the field. So if it was an actual magnet instead of a nail, the actual magnet just would have moved, but if it was a magnet that you allowed to turn, it would have moved even stronger in this direction because the field is stronger in the sense that there's now two polarizations that you can maximize the strength of that field. So these field lines are tighter here. But again, the lines are just a representation of the strength and orientation of the polarization.
They're being sucked into this ferromagnetic.
Right. So you think that's the way to say it? It's that there's actual something being sucked somewhere. That there's actually field light or something bending and sucking. There's no sucking. There's no flowing. None of that's happening. There's just two light bulbs right now. One shooting red light, one shooting black light.
Material. It's very hard to know exactly how they go. And the field here will weaken.
There you go. Now, I'm saying that's completely wrong. Nothing happened to this field in the sense that the same amount of red from this north end is hitting it. The same amount as before. And the trick is if you had a nail that could turn this way, the nail would be even happier to be here. It would be delighted because now it's getting maximum strength from a north-south relationship and maximum strength from a south-north relationship. So it would be maximizing the pull of the configuration. So the only thing that made this difference is that this was a ferromagnetic material, because if it was a real magnet, all that would have happened, if the nail was a real magnet, all that would have happened is as you move this south pole in, this would still be just as strong, and all the south pole would do is push it this way a little. It would push the nail, but the nail wouldn't drop.
And I'm going to demonstrate that to you. That is actually very easy to demonstrate. The way I'm going to demonstrate...
So he's not going to demonstrate any of this. He's not going to demonstrate, he's not going to make it understood that what really happens in magnetism is that a bunch of rays of virtual photons are conveying the magnetism, and they do that in this radiation, like a light bulb manner. That's physics he does believe in, but that's not physics the way he described it.
That is as follows. I have there a setup whereby we have a magnet and we have a nail and we have a string.
Right. Now, so all he had to do to fundamentally change the results of this experiment was to take the nail and tie it this way so the nail could pivot. And if the nail could pivot, then one end would go north, one end would go south, and the field would have gotten stronger when he moved the wrench in, and the nail would have stayed.
And the nail wants to go to the magnet. The nail itself is...
And again, wants to go to the magnet in technical speak. Okay, in reality, what that means is there's low pressure between here and high pressure pushing, so the high pressure wins and the nail is pushed into the magnet. And the magnet is pushed towards the nail.
Ferromagnetic. So the nail loves to go this direction, but it can't. So it just sits there, it hangs there in space. First of all, what I want to show you is that if I bring paramagnetic material in the vicinity, that magnetic field configuration here is not going to change at all.
Okay, so not going to change at all was kind of incorrect, because it's not going to change in the sense that you're just going to make the field stronger, not weaker. And not stronger by much, but stronger. And clearly it matters on how quickly you move the thing in and out. If you move it in slowly, yes, you could possibly disrupt the nail, because the nail again can't change its north-south orientation, so it can't remain a consistent magnet. It can't spin like the compass needle can, so it can't find a good location to line up with what they call these field lines that are imaginary. They're not real lines in real space. And once they're created by real substance, once you put iron filings in here, the iron filings start to also do the same thing as magnetically repel each other, because they're lining up with the field from the magnet, and so they're all in phase, and being in phase is not a good thing to be.
Paramagnetic material is a kappa and so close to one that nothing is...
Let me just point out what I mean by in phase quickly. So we're back to this little diagram of the magnet. So all of these magnets, I see these dots, you can see they're staggered. So the north end has to be next to a south end. The south end has to be north to a north end. So that was the only way they can have cohesion and consistency. They have to be out of phase. But if I put iron filings in, the iron filings won't be in phase, because this black here will end up lining up with this bottom. And so they'll all be in phase, which means they'll push away from each other. That's why the field lines exist, essentially, is because all the iron filings pile up and they repel the other line of iron filings. Instead of pulling together and just clumping into one big line, they can't because of that. They're all in phase, and being in phase means they repel.
Going to happen. But the moment that I bring ferromagnetic material, for instance here, then you get a field configuration change. And
okay, so field configuration change. Again, it's deceptive at minimum. You actually strengthen the total magnetic field. So if you could create a loop around this whole thing like this, and had one side south and one side north, that would be a much stronger field. So the more stuff you bring in, the stronger it gets. The problem is the inverse square law is in effect on the magnet. And so it really, what really, like the idea that, you know, when you stick a magnet on something, it gets weaker and weaker as you put more non-magnetic material on it. Well, what's really happening is you're getting more further and further away from the real source of the magnetism. And so the inverse square law starts taking over, and that's why it can't get any stronger, is because the new pieces of ferrous material can't become as magnetic because there isn't enough magnetism by the inverse square law to make them magnets.
If I do that just the right way, then the nail will fall. In other words, there is not enough magnetic field here.
Okay, so we just said there is not enough magnetic field here. Actually, these lines got much tighter together. This is a very strong field. Compass needles would go crazy in here. Very strong, very strong, very strong. So the field is stronger, not weaker. It's just that the field is mixed. So you have to be oriented right to it. So if your compass needle can't spin, it's a weak field. But if your compass needle can spin, it's a strong field, very strong.
In order to hold the nail in that direction. And I'm going to show that to you there.
Alright, well, we'll speed over some of this because we already saw this, and so we'll jump to where he, oops, doing equations. Yeah, we'll do where he moves the wrench in. So here, I mean, the ferrous stuff, when he puts his hand through and stuff, I don't need to go through that again. I think I explained what's really happening there. So we'll go with his finishing line again. And I'll just point out that he's the one talking intuition. I'm the one talking technically correct.
And there goes the nail. So what you saw now in front of your own eyes is that I changed the magnetic field configuration in such a way that the field was not strong enough.
There. The field wasn't strong enough. I mean, that's what he said, Hoffaday. Now, what field is he talking about? Because the only field that got weaker was the field created inside the nail. The nail's magnetism decreased because it lost its coherency. Instead of having all these reds pointing this way and blacks pointing that way, it now has the problem where this row of magnets is actually red, 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 red at the bottom, and this one's black at the top, and this one's red, and so they're misaligned, effectively competing with each other, and therefore neither pole, neither the North Pole or the South Pole, could hold up the nail anymore because the nail was neither north or south. It wasn't either one enough to be strong enough to sustain it. And so what he said is not the same thing I said, and clearly my argument's the technical argument, his argument's the intuitive argument. So your comment is baseless, it's grossly inaccurate, and it's fucking offensive. I'm just so sick of this bullshit. You know, look, I'm just going to give people, I'll give you fair warning. I don't make intuitive arguments. I haven't spent years watching douchebags like this. Sorry, no offense. But it's pissing me off. I haven't spent years doing that to make intuitive arguments. My theory is detailed and explicit, and there's no intuition involved here at all. I'm educated, you're ignorant. That's the fucking truth. I understand these processes, you don't. That's the fucking truth. So if you use the word intuition, you're getting blocked. So, yeah, fuck you, douche.